meter square, and also the in this case air conditioning. For the air conditioning reverse cycle, so that will can be there's a line and power is a 50 volt per meter square. Office reverse cycle air conditioning 25 volt per meter square. This is for the office. And also for the retail shop, light power and the air conditioning. So there can be the every 70 light and power is 70 volt per meter square. Air conditioner 30 volt per meter square. So those are the tables you have to refer. So you have to refer the light and power for the office is 50 volt per meter square. And also the reverse cycle air conditioning, we have to refer the 25 volt per meter square. And retail shop, light and power is 70 volt per meter square. Air conditioning the 30 volt per meter square. So those are the volt per meter square are given for this kind of the installation. So that in this case, this problem, we refer as raw data. And we substitute the data here. So for the shop, light power is the dimension 280 meter square and multiply with 70. So therefore, then we multiply with 70 multiply 280. So you got a 1. So that's 19600 we got. This is both end. For the air conditioning, the dimension is 280 meter square and 1 meter square 30. So that we substitute. So the multiply 30 minus 280. So you got an 84004 n. For the office light and power, the area is 250 meter square. 1 meter square 50. So 50 multiplied 250 meter square, you got the 12500. And also the air conditioning, dimension is 250 meter square and then 1 meter square 25. So you multiply, so you got the 8250. So we add everything, all the things, so you got the 179500 we got. So this is the thing we calculate for the test problem. So after you got this a short and office, so the maximum demand have to be calculated. So we calculate the maximum demand. So that in this case, short maximum demand is this one to the power, and office is this one. So the short maximum demand is 28000. This is the both end. So divided by root 3 into voltage. So the voltage 400 volt line voltage. So we got a 91 ampere per phase. Also, for the office maximum demand, you add those days, you got the 1,89500. So 1,89500 divided by the root 3 minus by 400, you got the 28 ampere per phase we got. So this is the thing we got the thing. So that in this case, which one is bigger? So we had to find out that so this is the in this case 41 ampere per phase. So in this case, cable size we can utilize 50 ampere, and also the 28 and 32 amperes HRC Q we had to utilize. So cable size means so 22 wise 32 ampere. This is the way we calculate it. The next one is how many 10 ampere socket outlets could be connected by the 2.5 millimeter square cable and 60 ampere circuits breaker in a non-domestic installation without permanent air conditioning. So this is without permanent air conditioning. So how many 10 ampere socket outlets can be connected? In this case, cable size is given a 2.5 millimeter square cable, and then we utilize a 60 ampere circuit breaker. So in this case, we had to utilize AS3000, table C9 had to utilize. So this is the table C9. We look at the table C9, AS3000 table C9. So this is the table C3. So go down, table C4, table C5, C6, C7, C8, and the C9. So we calculate the table C9. So this is the way where we use the table C9 here. So in this case, the size here is a circuit breaker rating and the cables are size. So given the two are given. So in this case, we refer to this table C9. In the problem, we use a 60 ampere and 2.5 millimeter square. So in this case, non-domestic installation. Non-domestic installation, 2.5 millimeter square and a 16 ampere. So here, 2.5 millimeter square and a 16 ampere. This one, non-domestic installation. In this case, you can connect the 10 ampere socket out and minus 2. And this is for the non-domestic installation without permanent air conditioning. If you connect the 10 ampere socket out there, you can connect the 2. But all domestic installation, non-domestic installation, and permanent air conditioning, in this case, you can connect as one number of the 10 ampere socket outlet. And 15 ampere single phase multi-phase socket outlet, you can install the 15. And also the 20 ampere single phase socket outlet not applicable. Maximum connected load is up to 5,000 watt you can utilize. So this is the ways if you use a 2.5 millimeter square and circuit breaker is 60, no way you have to utilize. In this case, you only utilize a 0.5 as a lighting point. So therefore, this program, so in this case, 2 ampere per point you can utilize. So every point it can use a 2 ampere. This is a current rating. So in this case, the current rating is if you connect a 10 ampere socket outlet, so 2 ampere every point it can utilize a 2 ampere current. So therefore, the 2 ampere per point we can calculate it. So therefore, every socket outlet is 2 ampere. Okay, but circuit breaker rating is 16. So the 16 divided by 2 ampere, so you can connect the 8 point. So this is the way we calculate it. So non-domestic installation without air conditioning. Non-domestic installation without air conditioning. So this table, 2.5 millimeter squares are cable side and a 16 ampere circuit breaker. So the every 10 ampere socket outlet, it draw the 2 ampere. Every socket 10 ampere socket outlet is drawing the 2 ampere. So that we use a 16 ampere circuit breaker. So this 16 divided by 2, you got it. You can install the 8 number of the socket outlets. So this is the way we calculate it. In this case, if you use a lighting point, each lighting point is drawing the 0.5 ampere. So then how many lighting points you can install? So 16 divided by 0.5, you got it 32 points. But if the installation the permanent air conditioning, it will draw the 1 ampere per point. So that for the 16 ampere, so 16 divided by 1, you can install the 16 point. But 15 ampere socket outlet, it can draw the 15 ampere. So this is it's drawing the 15 ampere. So for the 16 ampere circuit breaker, you can only utilize one socket outlet. So this is the way we calculate it. In this case, total power can be installed is 5,000 watt. So this is the solution of this problem. A final circuit in domestic installation consists of the 5 single and the 6 double 10 ampere socket outlet. How many 10 ampere socket outlets could be added to this circuit when it is supplied with a 2.5 millimeter square cable and protected by the 20 ampere circuit breaker with air conditioning? So this means that in the final circuit, we include the 5 number of the single socket outlet and 6 number of the double socket outlet. So each got is 10 ampere. So in this case, how many 10 ampere socket outlet you can add? So this circuit is supplied with a 2.5 millimeter square cable, protected by the 20 ampere circuit breaker with air conditioning. So in this case, we also refer the same table. So the table C9 you have to utilize. So table C9 is given here. In this case, you can know about the 20 ampere circuit breaker and 2.5 millimeter square cable. So you see the 20 ampere circuit breaker, 2.5 millimeter square. 2.5 millimeter cable, 20 ampere. So this is the here 2.5 and the 20. Cable side 2.5 millimeter square, circuit breaker side 20 ampere circuit breaker. In this case, if you install a lighting point, each light point will draw in the 0.5 ampere per point. If you install a non-domestic installation without permanent air conditioning, so each point taking the 2 ampere, and with permanent air conditioning, it will draw the 1 ampere. And so this is the given here. So in this case, you can see the 10 ampere single socket outlet. So that can be the how many socket outlet you can install. So 10 ampere single socket outlet is a 5 single socket outlet. So this is 5 number get already installed. 10 ampere single outlet 6 number double. So in this case, 6 multiplied 2, so 12. So this is the total 10 ampere socket outlet 17. This is the total socket outlet you is already installed is 17. But how many socket outlet can be installed? So you can see that this is a 2 ampere. So this is the with the permanent air conditioning. So this is the 1 ampere per point. So the 1 ampere per point. So this is to the circuit breaker rating 20. So 20 divided by 1, you got a 20 number of points. So the 20 number of points are you can install as a maximum. But it's already installed at 17. So that this is 20 minus 17, you get an additional 3 points. So this is the we calculated. So this is the way we calculate that problem. So the 20 minus 17, you got a 3 number. And the next one is a 5 number of the double 10 ampere socket outlets. They are connected with the 2.5 milliampere square cable, protected by the 16 ampere circuit breaker and the office with permanent air conditioning. So this is the cable size is 2.5 millimeter square and circuit breaker size 16 ampere circuit breaker. So we install the 10 ampere socket outlet. So the 5 number of double 10 ampere socket outlet means you can see the all of these are you got the 5 multiplies are 2. So that way the 10 number is already installed. So 10 ampere socket outlet already installed 10 number. So we have to add the additional how many additional point can be added. So firstly we refer the table C9. Table C9 is a 2.5 millimeter square, 16 ampere. So you can see the table C9, 2.5 millimeter square, 16 ampere. 2.5 millimeter 16 ampere here. In this case, 10 ampere socket outlet, you can add this 1 number. So this is the 1 ampere per point. So in this case, we find out here 1 ampere per point. So the 1 ampere per point, so total ampere is 16 ampere because we use a 16 ampere socket outlet. So that you can use as a total number is 16 divided by 1. You can add the total number is 16 point. So total number already 16 point. But we already got a 10 number because of the double 10 ampere socket 5 number of the double 10 ampere socket 5 number by 2 you got a 10. So the total is 16 minus 10 you got this as 6. So you can add the additional 6 point. So this is the we calculated. So additional 6 point we calculated this plane. And also the lighting point. In this case lighting point you also have to calculate that. So lighting point is a 2.5 millimeter square 16 ampere. So it's a 0.5 ampere per point. So the number of light can be installed. So in this case this is about the additional cut available is a 6 ampere because of the 10 ampere socket already all socket outlets already taken the 10 ampere. So the total available is a 16 minus 10, so you got a 6 ampere left. So this 6 ampere is how many lighting point can be installed. So that you see that at this table. So lighting point calculation, this table you can see it. Lighting point is a 0.5 ampere per point. So every 1 point is drawing the 0.5. So the total current is a 6 ampere. So 6 divided by 0.5, you got a 12 light. So you can add another 12 light. So this is the way we calculate it. So this problem is firstly we find out the 2.5 millimeter square cable, 16 ampere circuit breaker. So the 2.5 millimeter square 16 ampere circuit breaker. So every one circuit break one light. One socket outlet drawing the 1 ampere because of the across room that this table singles are domestic installation. So that will be 2.5 and the 16. So that is withdrawing the 1 ampere about the point. So and then 16 divided by 1, you got a 16 point. So firstly, we got a 16 point. But how many point already installed in? We can calculate that. How many point you already installed there? 5 number of 10 MBR, so the 5 minus 2, you got a 10 already, 10 number. So the this 16 minus 10, so you got a 6. So this is a lab. Only 6 MBR is available. So this 6 MBR, we have to install the light wire. So the how many light wire can install according to this table? Light wire is a 0.5 MBR per point. So the 6 divided by 0.5 MBR point, you got the 12 number. So light wire you can add this additional way the 12 number we can calculate that. So this is the things we calculated this problem. Okay, the next problem. A mid circuit in the home has the 690 watts combined heat exhaust fan. So the mid circuit in the home has a 690 watt combines exhaust fan and heater and the light. They are connected to the circuit. If the circuit is protected by the 60 MVR circuit breaker, how many 10 MVR socket outlet can be connected? So this will be the 2.5 millimeter square. This is for the given side and 60 MVR circuit breaker. So in this case, original load is a 690 watt. So to the load is 690 watt, so that this load is a 690 divided by supply voltage 230. So you got the 3 MVR already take out. And how many socket outlet will that? So that will be a 16 MVR minus 3, you got a 30 MVR. So 30 MVR is available for the socket outlet. So how many 10 MVR socket outlet can be connected? So you refer the table C1. Table C1 is, in this case, this one is a domestic installation because of the 10 MVR socket outlet. This will be the domestic installation. So this is the, we refer to the table C1. So table C1 is this is the table C1. We refer. Go up and we find the table C1.
Oh my God.
So table C1 here, this is table C1. So load group lighting point. So the first 1 to 20 point, it will take in a 3 MVR. Additional 20 point, it takes a 2 MVR. So this is the rule for the table C1. So this is the rule for the table C1. So the load group, this is for the 10 MVR, this is the lighting point. And for the socket outlet, load group is a B1. So the 10 MVR for the first 1 to 20 by 5 MVR for the additional 20 by. So this is for the single domestic installation. First 1 to 20 by is taking the 10 MVR. So therefore the this program first 1 to 20 by. So this is for the current is a 15 MVR. So 15 MVR is a we can add the installation up to the 40 by because 15 MVR means the first 10 MVR 20 by and another 5 MVR is also the 20 points, so total 40 points we can add that. So if this program current is now 30 MVR, and 30 MVR means so you can use a 30 MVR, so the so 10 MVR is additional 20 points, but 13 minus 10, so that only the additional 5 MVR. So 5 MVR is unsafe because of the we need is 13 minus 10, so you got the 3 MVR left. This 3 MVR is not enough for the to install the additional point because I need the 5 MVR. So there is safer to install the only 20 point. So this is for the that installation, and those cables are we given. Okay, this program 2.5 millimeter square cable, 25 ampere circuit breaker, non-domestic installation without air conditioning. So how many lighting point can be installed? And how many 10 ampere socket outlet can be installed if the only socket outlet in the circuit? And if the 12 ampere allocated for the 10 ampere socket outlet and the 30 ampere for light, how many light and the 10 ampere socket outlet can be installed? So that if you install the only lighting point, so we refer the table C9 so that every light point taking the 0.5 ampere, so that there will be there will be 25 ampere circuit breaker, 25 ampere circuit breaker, 25 divided by the 0.5, you got the 50 light. You can install the 50 light. But only socket outlet installed. So this is for the without air conditioning. Without air conditioning, table C9 you look at. So this is the table C9. This is table C9. Table C9 without air conditioning. So 25. So this is for the without air conditioning. This is for the socket outlet 2 ampere point. So 2 ampere point we can install. So this is for the 2 divided by the 25 ampere. So you got 12.5. So if we can install it up to 12 number of the 10 ampere socket outlet. And if you locate only 12 ampere socket outlet, so that this is 12 divided by the 2 ampere point, you can call it 6 number of socket outlet. If you install it only 30 ampere for light, so each light light point drawing the 0.5 ampere, so 30 divided by 0.5, you call it 26. So here is a light point, we require the 0.5. For the 10 ampere socket outlet, we require this one because without air conditioning. Without air conditioning, 10 ampere socket outlet, every socket outlet taking the 2 ampere. Every light point is taking the 0.5 ampere. Therefore, this problem, so how many light point will be required? So in this case, to the 30 divided by 0.5, you got the 26. And also the socket outlet 12 divided by 2, you got the 6. So this is the way we calculate it. So this is the way we calculate for the this problem. So this problem means you are provided with the cable side and also circuit breaker. So based on your cable size and the circuit breaker, how many light point, how many socket outlet can be installed. So the condition will be that with air conditioning and without air conditioning. Therefore, we refer the table C9. So table C9, you can see the cable crossing the area and the rating of circuit breaker, lighting point, we refer to this column, and 10 ampere socket outlet without air conditioning, we refer to this column, and permanent air conditioning, we refer to this column. And if you are installing a 50 ampere socket outlet, we refer to this column. 20 ampere, this column. So this is the way we calculate how many socket outlet and also light point can be installed. So let's bring the installation condition. So when you want to install the electrical installation, important one is that you have to find out the current rating capacity. So current rating capacity is the maximum continuous current that is the particular cable can carry without overheating. So this is for the meaning of the current carry rating capacity. This is the meaning of current carrying capacity. Current carrying capacity is maximum continuous current the particular cable can carry without overheating. So the best current carrying capacity influenced by the ambient temperature. Ambient temperature is surrounding temperature and also the type of cable, also installation. So that in this case, B75 that you can utilize 75 degrees centigrade up to utilize. V90 is that we use as a temperature is 90 degrees centigrade. And V110 is 110 degrees centigrade. So that is a kind of the cable. Those kind of cable also influence the current carrying capacity. In the meantime, we also need to concern about the installation method. Enclosing air, in this case, we will refer the EL0018 table 31. And enclosing airs are table 32 are enclosed in underground. Table 3 and are enclosed underground is a enclosed underground is 3-4. So those table we have to the power. So those are kind of this are installation, type of installation, current carrying capacity, and ambulance are ambient temperature. All are the affecting the current carrying capacity of the cable. So this current carrying capacity is maximum continuous current that a particular cable can carry without overheating. So that in this case, we also have to find out the, depending on the installation condition, table 3-1, 3-2, 3-3, 3-4, utilized to the determine the size of the cable. In this case, the 3-5 mean that we install the cable in this way. Lay flat is as a touching this way we can install. Lay flats are separating is this install this kind of installation. This is the 3-5 or lay flat touching or lay flats are separation. The way to install the cable. Now, of course, remember that the para tables are linked to the table 3-1, 3-2, 3-3, and 3-4. So in this case, we have to determine the cable size. Also, there we can need to calculate the cable voltage drop. In this case, we have to refer the ASR 3008. Table 40 to 50 is utilized to calculate this voltage drop, and also the derating factor. The derating factor indicated by those are tables. So the derating factor and the voltage drop calculation, cable size determination, they have to they are the have to be the calculation process. So by referring the table 3-1, 3-2, 3-3, 3-4, we have to determine the cable size. We need to determine the voltage drop by using the table 40 to 50, and also we have to determine the relating. So this is the way we have to calculate. Okay, so that we have to solve this problem. A three-phase single core cable can enclose in L V75 TBI cable. Is supplying at 25 ampere. So this is the enclosed in L V75 TBI cable, thermoplastic insulated. It is supplying the 25 ampere. So we have to determine the cable size and also voltage drop. So the cable is at 42 meter long. We need to find out the voltage drop. So in this case, the enclosed in L means we have to refer the cable 32. So table 3-2 has to refer. So 3 single core cable, it does not say about the insulation. So therefore, the 3 single core cables are insulation, so that we have to refer the AS 3008. So in downside, we are using the AS 3008. So that I open the AS 3008. So AS 3008 table, we refer the tables are 3-2. This is the AS 3008 table. Then we use a table 3-2. So go down. We look at the table 3-2. So table 3-2 is here. This is table 1. So we look at the table 3-1, 3-2. This is table 2. Table 3-1. Table 3 are enclosed in air. Table 3-2 is enclosed in air. Table 3-2 is enclosed in air. So this is 1. So 3 single core cable. So the problem given the 3 single core cable, so it does not mention about the insulation. So we have to refer the item number 2. So item number 2 is this one. Item 2. 3 single core cable. It does not mention about the insulation. So the including A, this one 3 single core cable. So in this case, table 7-8, column 15 with 17. On the table 9, column 11, 12. So in this case, V75 is at table 7, and V9 90, and then this one, and the V110 is at table 9. So this is the wave that we have to refer the cable. So this is the angle. So Table 7 for the 75 degrees centigrade, table 8 for the 90 degrees centigrade, and table 9 for the 110 degrees centigrade. So in this case, we utilize a V75. V75, we refer to table number 7. So this is table number, column number 7. So this one is a column V75. Now, table number 7, you have to refer. So the table number 7, column 15 to 17. Because table 7 for the V75, table 8 for the V90, and table 9 for the V100, V110. So this problem is given as a 75 degrees centigrade of V75. So we follow the part to the table 7. Table 7, column 15 to 17. So that we look at the table 7, go down, table 5, table 6, and table 7. Table 7 is column 15 to 17. This is column 15 to 17. Column 15, 16, and 17 we utilize. So the column 15 for the copper solid stranded, 16 for the copper flexible, 17 for the aluminum. So that this problem, it does not give us, so we assume that they're solid stranded. We don't use the flexible in the installation, we don't use the aluminum based on this given is the copper we utilize. So the copper solid stranded, so we refer the table number 15. So table number 15, we have to refer. So this is the which table you have to refer. So the nouns are we utilize the table number 15. So in this case, we also have to calculate the given side. Given side, so the solids are stranded given utilized. So in this case, how many current is given? So this is the supply of 25 ampere. So current requirement is 25 ampere. So current requirement 25 ampere. So that you can look at here. So the 21 ampere is a small, and so the 28 ampere is the better because of the this solid stranded are given. We utilize 28 ampere. So that in this case, we utilize the 4 millimeter square. The cable size is 4 millimeter square. Therefore, we utilize the cable size 4 millimeter square. So this is the way we calculate cable size 4 millimeter square. And then we also have to utilize the body draw. So body draw is a way to refer the table 40, 41, 42, 43, 44, 45 up to the 50. So those are table utilized to calculate the body draw. Table 40 for the copper single go 35. Table 41 for the copper single go, and so that's way and a wiring enclosure. Table 42 for the copper mardigo. Table 43 is the similar to copper single go 35. Table 44 for the table 43 for the aluminum single go installation 35. Table 44 for the aluminum single go in the wiring enclosure. Table 45 for the aluminum mardigo. And 46, 47, 48 are for the flexible cable. 49 is a MIMS cable, and the 50 is an area cable. So this is the ways depending on the kind of the installation, you have to select the appropriate cable from the 40 to 50, depending on the your installation. So this installation is how the cables are utilized. So there will be enclosed installation. 3 single go cable enclosed in the air. So this is 3 single go enclosed in air. So therefore, we refer that this cable is which cable here to utilize. So so enclosing air. Enclosing air, we have to refer the table 41. 3 single go cable enclosing air. Because of the 3 single go cable enclosing air is an appropriate table 41. So then we find out the table 41, and also the temperature is 75 degrees centigrade. Size is 4 millimeter square. So we look at that table 41. So go down, we look at the table 41.
Checking finance now with Stephen Dagley in the ComSec. Hi there, Steve. What helped push our market higher today?
Table 41. One in Nina way of my Joe, we don't know, change table 41. You know, lay on Senania Lama, a little while. Table 41. Table 41. So look at here, table 40 and table 41. So this is table 41 here. Table 41, so the size of 4 millimeter square and 75 degrees centigrade, so that there will be the 9 by 71. So this is for the BC value. The BC value have to be utilized in this formula. This is for this equation have to utilize this formula here. BC is a body draw BC Li by 1000. So this BC, you have to utilize a millivolt ampere meter. We have to refer the table 40 to 45. And A is the length of the cable, I is a current. So BC you have to utilize. So this BC here, table 40 for the single core, table 41 for the copper single core, enclosure, and table 40 for the copper multi-core. 43, 44, 45 are the aluminum, and 46, 47, 48 for the flexible cable, 49 for MIMS, 50 for area. So this is for the BC calculation. So this provides cable size 4 millimeter square, 75 degrees centigrade with the part table 41. So with the part table 41, this is table 41. We apply it 4 millimeter square, 75 degrees centigrade. So this is 9 by 71. So you use it 9 by 71. 9 by 71 is for the BC. And length is the 42 meter. Current is 25 ampere. So BC element 1000, we call it 10.2 volt. We calculate.
Australia's richest people for 2022 have been named.
So this will be the 19 points are 2 volts are we calculated. So the 10.2 volt is a voltage drop and supply voltage. It must be the less than the 5% of the supply voltage. Supply voltage is at 230 volts. 5%, 230 divided by 5%, we calculated is that will be the 11 by 5. So 11 by 5 is a so that we calculate is a 10.2 volts, less than the 5% of supply voltage. So this is the acceptable. So the next one is 3-phase voltage drop. 3-phase voltage drop and single-phase voltage drop calculation. So then, if you are using the single-phase voltage drop, it's a 3-phase voltage drop divided by 3, or this single-phase BC is a 3-phase BC divided by 8.66. So that all the tables are 40 to 50. In this case, we got the 3-phase BC. So this 3-phase BC need to be divided by the 8.68. Then you can calculate the BC value. So that if well, usually you got the table 40 to 50. Those table 40 to 50 are for the 3-phase BC is a given. So based on the 3-phase BC, if the problem is a single phase, so the 3-phase BC can be calculated converted to single phase BC by using this formula. And similarly, there is a voltage, 3 single phase voltage draw and 3-phase voltage draw relationship. Single phase voltage draw is a 3-phase voltage draw by √3. Or the single phase BC is 3-phase BC divided by 0.86. So this is the way. So from the table 40 to 50, what you got is a 3-phase BC. So that if the problem is a single phase, you have to divide it by 0.86. So that this one is the if the problem is given in a 3-phase BC table 40 to 50, we have to utilize directly But if the problem is a single phase, so that in this case, single phase body draw given, in this case, single phase body CBC is a 3 phase given by AC to be applied. So this is the way we calculate it. Okay, the next problem. Two single phase socket outlet installed on the circuit provided by the 32 ampere circuit breaker, V75 TPI, and closing and non-domestic installation, then is a 50 meter. So when you select the cable side, you have to find the voltage draw and then you have to justify with the EL3000. So the two single phase socket outlet installed on the circuit provided by the 32 ampere circuit breaker. So the V75 TPI enclosing a non-domestic installation. That is a 50 meter. So we have to select the cable side, find the voltage draw and justify with the EL3000. So the enclosing A. So this is the table 3.2 is a glass. But this is the thing we tell about you. You must check me out again.
မလေးကြောက်ပြီးမှနေလုံးရတယ်
မလို့
တတိလာတဲ့အချိန်ကငါကြည့်ရမှာပဲတတိမဲ့ကြည့်ဖို့ရေးကြည့်တာဘာဖြစ်လို့ဖြစ်မှန်းမသိဘူးယောဂပူ
enclosing A is a tables are 3.2 have to utilize. So that in this case single phase is 2 singles are 2 cable. So that in this is a table 3.2 enclosing A. So table 3.2 is an enclosing A where do you utilize?
In 2008, Australia zeroed in. The Labor Party soon changed that. The Liberal Party continued the trend of excessive national debt, throwing out vote on the United Australia Party in Save Australia, authorised by Clive Palmer for the United Australia Party Brisbane.
For 2 single go cable. 2 single go cable. So which one have to utilize? 2 single go cable. 2 single go cables are enclosing A. So in this case, which item have to utilize? So this 2 single go enclosing A. So item number 1. Item number 1, table 4, 5, and table 6. So table 4 for the 75 using rate, table 5 for the 90 using rate, table 6 for the 110 using rate. So those they have to utilize, table 4, 5, 6. So then, so you can see that this is a problem here. Table 4, 5, 6. So table 4 for the V75, column 15 to 17. So column 15 to 17. So then, in this case, current is a 32 ampere circuit breaker. 32 ampere circuit breaker given. So this is the table. Table 4 is a column 15 to 17. So table 4, V75. So table 4, this is for the 75 disintegrate. Column 15 to 17. So we look at the table number 4. Table number 4. Column 15 to 17. This is column 15 to 17. So the solid standard is for the copper. Flexible is copper is a solid standard for the column 15. Flexible copper is column 16 and aluminum is column 17. So in this case, we use a solid standard and 4 millimeter square. 4 millimeter square. So this is the 32 ampere circuit breaker. This is 32. So then with cable side we use 4 millimeter square. So cable side we calculate the 4 millimeter square. So after that, we have to justify with the voltage draw. So the voltage draw is a we have to find out which cable have to utilize. So then that will be the how this one installed. Cable 40, 41, 42, like this. So in this case, install on the circuit, no? Socket 2 single go. 2 single go is how the cable installed. You are here. This is copper single go at 3.5. Here is table 41 enclosed. So enclosed means you have to refer the table 41. Table 40 for the copper single go. That is 3.5, but the single go enclosed is table 41. So this is in the wiring enclosure. Table 41 has been utilized. So table 41. From this table 41, based on the 4 millimeter square, you have to find out the VC. So the table 41, we look at, then we find out the VC. So the table 41, you go down, we find the table 41.
It is a grey night in store for Sydney with those showers and storms likely. Tomorrow we will see the rainfall ramp up a little bit.
So this is the table 41 we got. So table 41, 4 millimeter square. 4 millimeter square. So that will be there. This is the side of the cable here. And 75 degrees centigrade. 4 millimeter square, 75 degrees centigrade. So the V75 is a 9/71. VC is a 9/71 we got. So you calculate VC 9/71 millivolt per ampere meter. So this is for the 3-phase VC. But this problem is given a single phase. Therefore, this VC has to be converted to single phase. So the 3-phase VC divided by 0.86 single phase. So 9/71 divided by 0.86, 11/2. This is the single phase. And then we did the VC 11/1000. So VC 11/2. Then on the circuit is already given the 56 meter. Current is at 32. So 56 and 32 and 11/2 divided by 1000, you got a 20/1. So the 5% of 230 volt is 5 minus 100 minus 230, 11/. This one you got the 11/6. So the 20/1 answer not acceptable because of the greater than the 11 point, greater than the 5% of supply voltage. So this selection, we select the 4 millimeter square. This value we substitute. The value is more than the 5% supply voltage, not acceptable. Therefore, we select the bigger side. Bigger side, you select you substitute the 6.49. 6.49 have to be substitute. Therefore, this 6.49 is substitute in this problem, this formula. So 6.49 substitute. This 6.49 by 8.6 is 7.49. So the VC by 1000, so 7.49 minus 76, PVC minus 32 by 1000, you 30/42. So there's voltage draw is a supply voltage 5%, 11/5, now 30/42, not acceptable. So we can select this 6 millimeter square. Therefore, you select the bigger side. Another bigger side is you select the 10 millimeter square. 10 millimeter square, you can substitute the 3/86. So this 3/86 substitute here. 3/86 divided by 0.86 is 4.45. VC by 1000 to 4.45 is a VC. A is a PVC. I is a 32 divided by 1000 to 7.49. So 7.497 is a less than the 5% of the supply voltage. So the acceptable. So that we select the cable 10 millimeter square. So in this problem, all those are we select the cable by using the table 41. Tables are 456 and 4 millimeter square cable, but the by the adjustment with the voltage drop, this 4 millimeter square is not acceptable. Therefore, we have to select the bigger side. Therefore, when you select the cable side, we select the cable side based on the current. But this is not enough. Accurately, when the cable is running low, it will draw the voltage. So that we also need to concern about the voltage draw calculation. Therefore, this problem, firstly, we select the cable by using the based on the current, but this cable side is not enough by using by calculating the voltage drop. Therefore, we have to select the bigger and bigger cable. So that we calculate the voltage drop and compare with the supply voltage, compare with the 5% of supply voltage, and if the accurate calculation is more than the 5% of supply voltage, this cable side is not acceptable. So that we choose another bigger side, and we recalculate again the voltage drop, and finally the 10 millimeter square cable side, the voltage drop is less than the 5% of supply voltage. So that time it is acceptable. So 10 millimeter square cable is selected. So this means that this problem we can utilize the voltage drop calculation. The voltage drop calculation by using the current and also by concerning the voltage drop.
The race against time to find a 4-year-old girl missing in the Tasmanian wilderness. And historically, accused sex offender Gareth Ward becomes just the second MP in New South Wales history to be suspended from Parliament. Joe Biden arrives in Brussels for an extraordinary NATO meeting on Russia. The alliance now set to double its troop presence.
Wait, the next month when you guys, I like to get trade prices before them. I like to get trade prices. Let to get trade prices 2 space for them. So now we're talking about the standby power supply. Standby power supplies are generally intended to provide the main power at a specified load and when the usual main power is unavailable. So the standby power must be important, especially for the hospital, airport, and emergency installation, where you utilize the standby power supply. And also the circular movement losing the power is a crucial movement losing the power is the emergency intensive unit. If you lost the power, it will cause a loss of the light and the data. This is why that we have to utilize the standby power supply.
Its advanced technology gives you access
So
to
the
more speed.
momentary loss of the power can be tolerated and residential lighting on the residential socket outlet and daytime operation of the household and the essential electrical items. So those items require the standby power supply. Interactive power supply is a connection here when the electrical load is associated with the device is supplying the essential electrical load. So when the main power supply off and then interactive power supply is the switch go to the interactive power supply and it continue to supply the load. The UPS systems are attached to the battery, so and also the diesel driven generator. So this is about the block diagram of the interactive power supply. Main supply it provides the AC, so that it provides a battery charger and a change to the DC, and batteries are supplying there's a DC to inverter, and then this inverter transform it to the AC and then supply to the load. In the meantime, AC is connected to the monitoring system. So that AC supply is a monitor, and then it can execute as a changeover switch. So the permanently floating the change from the input calendar. So in this case, we are using the PWM. Power modulators are utilized to attain the sideway output from the inverter. So therefore, the PWM inverters are utilized to produce the sideway. So this is the main supply here, AC supply to the load, or the battery. The AC also supply the battery charger, and batteries are connected to the inverter. At the time of this emergency, the inverter will supply the load through this changeover switch.
But if we all take better care of our clothes with the help of Vanish, which
so there are two kinds of this UPS, internet-based power supply. Offline UPS. So offline UPS is draw the current from the main supply and switch to the battery within a few seconds after detecting the main power failure. So this is the offline UPS system. So the main power supply, so normally it's connected to filter and connected to load, and normally it's battery charging. So when the battery charger charge the battery, when the main power failure, so that inverter supply to the load. This is for the offline UPS system. Online UPS system is interactive UPS. So interact with the power into smoke out the waveform. So the main power supply here, so we provide a filter and connected to load. In the meantime, battery charger also supply the battery to the load. So the online UPS is an advantage. It can continuously provide a clean power. So without it can only the automatic changeover switch by load. So the battery charger, battery inverter is supplying the load. So this is for the online UPS system. So offline UPS is main power pay is supplying the load. Online UPS is continuously supplying the load without whether main power free or not, is supplying the load. But when main power pay, the UPS state supply and load. So this is the online and offline UPS system. So this is the connection of the waveform. Inverter input is a DC and output will be the AC waveform. So that we use a solid state power supply system. We use the transformer, switching, indirect control circuit. So this is for the UPS system. So that you got the most FED driver. Also, this is a voltage limiter. So battery voltage limiter connected here, and most FED driver is driving those FED, and then the FEDs are making this switching waveform, it changing to the alternating current, alternating voltage, and the output is AC supply. So this is a connection of the FED circuit. So the inverter rating can be the continuous rating is a continuous power without inverter overheating. Half power rating is an oscillational application, and as share rating is a TV and a refrigerator. So this is for the surge rating is for the TV and the generator. So this is inverter rating. Normal waveform from the inverter is this is for the no square waveform. This is no good for the sensitive electronic equipment. Suitable only for the lighting. But modified sine waveform, and but this is a modified sine waveform. This is a fast wave pure sine waveform. So this pure sine waveform is good for the electronic equipment. So in this case, grid connected inverter is connected solar panel and connected to inverter, and this control sensor and connected to power load. The standby generator. Standby generator is a backup electrical system that operates automatically within the second of the main voltage, and the automatic transfer switch sense the power loss and command the generator to start and transfer the electrical load to the generator. So the standby generator is a backup electrical system that operates automatically within the second of the main blackout of the main power, and the automatic transfer switch sense the power loss, command the generator to start and transfer the electrical load to the generator. So this is the automatic transfer switch sense and main power loss signal and start the generator. So automatic standby generator application are utilized for the evaluator in the high-rise building, fire protection system, standby lighting, and medical life support system. So this is the utilizing of the standby power. So the factor for the switching of the alternator depend on the voltage, current, frequency, power, and the power factor. So this is the main power supply circuit breaker. This is the connection of circuit breaker and standby generator and electrical load. So CB1 is manually operated. CB4 is manually tripped, and disconnections are non-essential load. Standby generator start runs to speed. CB2 is closed. This supplying power to the essential load. So this is for the changeover switch system. So this is for the feeder 1, feeder 2, and this changeover switch and connected to the load. So this changeover switch system. So the changeover system is this is for the feeder 1, feeder 2, and this is 40 ampere. This is 11 kV, 450 volts, 750 kV system, 1000 ampere load, and also automatic transfer switch. This is all connected load. This is standby generator. So this is the configuration of the feeder power transformer, standby automatic transfer switch, and standby generator. When the main supply is lost, the control system sense the loss and operate the automatic transfer switch. In the same time, the standby generator started and then run up to speed. Once up to the speed, the standby generator then supplies the connected load. The control system will operate the appropriate circuit breakers to disconnect any non-essential service. So the type of the electrical converters are connected to the this is the uninterruptible power supply system. Also, we use the voltage stabilizer, motor generator, and the rotary inverter. Electricity converter must be installed with the independent isolation switch across the 4x12x4 of the ES3000. They must be installed with the independent isolation switch. So the electricity converters are protection. The every sub made on the final circuit outgoing from the electricity converter must be individually protected and as additional protection. So this is the cross 2x6 of the ES3000. So here will be the converter and load. They must not be adjusted by the PLC. Must not be bypassed by the PLC. So this is for the cross 4x12 and a 4x1. And RCD and electricity converter is we have to follow the 4x12 by 5x2 by 2 EL3000. RCD share we type of the switch for the waveform of the particular inverter. So other system is must follow the 4x12 by 6. Protected earthings are conductor shall not be switched. MVS are connection remain intact. Earthing for the engine driven generator set must follow the ASR3010. Standalone power system must follow the AS4x09. Automatic voltage array, photovoltaic arrays must follow the ASR5033 and inverter system must follow the AS4777. So this is for the appropriate Australian standard to be comply with the standby power supply system. So standby power system are items to provide the power at the specified voltage and frequency. So UPS is an interruptible power supply system. UPS are converted DC to AC. And R2 conductor must not be switched. And standby generator requires the prime mover that is powered by the diesel engine, liquid force spring gas, LPG, and natural gas. So this is converter and RCD. So RCD waveform must suit the inverter output. So there will be the difference between the inverter and the rectifier. Inverter is DC to AC conversion and rectifier is AC to DC conversion. So the across into there's a cross 7.3 incorporating the battery. So this is for the appropriate rule and regulation. Clause 7.3 of the year 3000 is the main concern about the incorporating battery. And adding to the other side, we must refer to the section 5. In this case, this formula, KVA into 10 power 3 divided by 2, 3, 400 volt, then we got the current. The current is, by using the current, we need to select the side of the protected relay adding. So in this case, we might utilize a table 5x1. The overcurrent protection device must be located as close as practicable to the output terminal of the electric converter so that the unprotected interconnecting conductors as a short circuit as a practicable. So the overcurrent protection device shall be located as close as practicable to the output terminal of the electricity converter so that the unprotected inverter connection conductors are as short as practicable. So this is the 4x12 by 5x1. Independence isolation switch. Each electricity converter shall be provided with the independent isolation switch in cross with the cross pipe 2x3 by 2x2. Electricity converter shall be arranged that it cannot supply the energy upstream of the point of the connection to the installation either directly or indirectly. This is the cross 4x12 by 3. So those are the appropriate AS3000 clause. That's a concern about the